So 10.5. Thermodynamical potentials and chemical reactions. Bless you. Okay. Now, all of the thermodynamical potentials that we have talked about are delta U, delta S, delta F, delta H, etc., are all extensive properties. Anyone remember what extensive properties are? They are dependent on the amount of material. Depend on the amount of materials. Is that a good start? No. So what do you want to do? You want to convert your extensive properties to intensive properties. Because you do not have to worry about the boiling point of water, whether you have 1 kilogram of water or 2 or 10 or 100. It should be standardized. So how do you go about doing that to convert your extensive properties to intensive properties? Divide by mass. True. However, in most circumstances, you can't do that. So what you do instead is to define specifically the conditions under which they become intensive. For example, specifically defining temperature, pressure, mass, and the physical state. And what we have done is that we have defined it to be at 25 degrees Celsius at a pressure of 1 atm and for 1 mole of substance. And when we do that, we change the properties to this. Magically. You add a 0 as a subscript, and you call it a day. Yeah, sorry, superscript.
Don't people use 20 degrees Celsius sometimes?
Nope, 25. That's how they defined it.
We're not defining
So
it.
on standard conditions, your extensive properties become intensive, and somebody defined it to be at 1 mole, at 25 degrees, and at 1 atm, period.
We don't need it.
Because you needed some reference, and so that's what the reference they defined it for.
Yes.
1 mole.
The state?
Oh, so that depends on whether it's liquid, solid, or gas, right? So they will have to tell you what state they're talking about. So in your chemical reactions, you will always have something like a L or a G or something, right? That tells you the state. But mostly we are concerned about temperature, pressure, and the number of moles. Got it? So this is standard. I think they call it standard state. I should write that down with pink. And the standard state is defined as this, and the values at the standard state will be given by those. If you see a subscript, you should know what that means. So let's do an example. So in 10.5.1, I've given you guys an example, which is burning of propane. That depends on how much propane you have. But we would like to standardize the reaction. So if I look at 10.5.1, it gives you a reaction CH3, CH2, CH3 gas plus 5O2 gas gives you 3 carbon dioxides gas. Andy, this is why we have to do that. Gas plus 4 water in the gaseous state. Okay, so the delta H of this reaction is actually an extensive property. What does that mean? The larger the amount of propane you have, the larger your delta H is going to be. So how do we make it into an intensive property? We use delta H0. We calculate it for 1 mole at 25 degrees Celsius and at 1 atm, and we call it negative 0.44 kilojoules. We put it in a table and call it a day. So somebody spent a long time calculating that number. And once that number was found, at 1 atm and at 1 mole and at 25 degrees Celsius, it was put in a textbook, in a table, and everybody uses it, making sure that you put a delta H0 on it. Okay? And then what does the negative sign mean? It is what? Exothermic. What does that mean?
That's easy for the environment.